Hi everyone, welcome to Leetcode contest weekly contest 300. And there's no time, so we'll just get started. This doesn't really make first appearance of each letter. Okay. I see. A linked list, what? Oh, okay. Okay, I think I've switched them around, so let me just switch around M and N. So we'll set them to named 1. If head dot val. AC. So what is it? We'll share after from delay days. And then I need to forget. What is this problem? I think I need to work out exactly what I'm being asked. So I'm just going to start with a slow solution and then I'll optimize it later. I need to figure out exactly what's been happening. What's this one first? Each person will forget. I only want to do this for correctness. I'm not actually going to submit this. So there's 3 and 5, which is wrong. Oh, what am I doing? dbi take j. So like on day 3, I think that might just be dbj. Yep. Okay. Forget, and then I need to do that's intake I. 5, 6. Okay, now that I've done that, now I can optimize it. Oh no. Oh, that should be db. 556. Oh, don't forget to modulo that. AC. Number strictly. Eight, 3. Fifteen, 4. This should be answer ID. Please don't TLE. Okay. I found that Q4 was a lot easier than the Q3. Anyway. The leaderboard doesn't seem to be updated yet. This person did beat me, so I didn't come first, but maybe I think I did pretty well, so anyway, I guess I'll go through the answers right now. Yeah, I'm not sure what my rank is since it hasn't updated. We'll go through the thing. Okay, this is a pure implementation question, and it's actually quite an annoying one, especially for Q1. So basically what I'm doing is, first I'm going to get rid of spaces in the key. Then it said something like, I had to read through here, you have to take the first appearance of each letter in the key. So how I do that is I'll iterate through the characters in key, and if I haven't seen it before, then that's the one that now will count. And then I need to align this with the English alphabet. So the way I've done this is, I'm basically iterating through the key and the alphabet, and then I'm assigning the values in a hash map. And that means that when I iterate through the message, I can just look up what character it should be in my hash map, and then I'll just set spaces to spaces. That was basically it. This problem, I'm so glad I copied this one from binarysearch.com because in this problem, you can also copy it from Leetcode, I'm sure. Basically, you're given the matrix and you need to find it in spiral order. Now, in this one, we actually need to, we start with a blank one, and we need to fill in the cells in spiral order. But we can still reuse the code of the spiral order. So basically, the way I do this is there's 4 different directions we can be going. We can be going like right, down, left, and up in that order. And that's represented by these dx and dy arrays. So if my current direction d is 0, that means that I'm going right. If d is 1, then I'm going down. If it's 2, I'm going left. And if it's 3, I'm going up at -0. Very nice. And then all I'm basically doing is x and y is my current position. And then for each of the cells, I will mark it as being seen. If this head links list is not empty, I'll fill it in. Then I'll attempt to move 1 step in the correct direction. Yeah, 1 step in my current direction. But if I can't go there because either it's out of bounds or I've already been there before, then first I have to rotate my direction by 90 degrees, and that's basically how it works. Alright. Okay, for this problem, just like, I don't know, it was just very hard to read. But basically, okay, here's the key idea. Let's say let dpx be the people who hear the secret for the first time on the xth day. The key relationship is like dpx will be equal to like, yeah, it's like x take forget plus 1 plus dp x take forget plus 2 plus all the way up to dp, I think it's x take delay, x take delay. The reason we have this strange dp relationship is because these are like the people who could tell x, who could tell the current person on the xth day. Like the day can't be past x take delay, because otherwise they haven't waited the full delay days of telling the secret. So if this was like x take delay plus 1, that's too recent. It needs to be before x take delay. Also, it can't be before x take forget plus 1, because if it's x take forget or before, then they would have forgotten it by then. Therefore, all the other people who are remaining in the range are able to tell some new person on day x, and that's why we have this we have this thing. So I started out by implementing this formula just to check if it was correct. And then once you do this, you notice that this dp array, these indices form some contiguous range, which means we can optimize this with a prefix sum array. So basically, as I build my dp array, we will let psa x equal to the sum of, we'll let that to be the sum of all dp values up to dpx. And then in this case, when I take this, that is just psa x take delay, subtract psa x take forget. And that way I can, instead of looping through this, which would be on time, I can just look up the prefix sum array, and that's o1 time. And yeah, that's pretty much it. I'll do my base cases. I have this range, which I talked about. This if x less than or equal to y, it might be unnecessary. I put it in because I didn't want to debug. I make sure to max it by 0 because I don't want to, you can't deal with negative days as well. Then I'll let the dp value be this range, and then I'll update my prefix summary. Oh yeah, and then for the final answer, the answer is just the people who heard this secret for the first time in the last forget days, because yeah, that's basically the answer. If it's before n take forget, they would have forgotten it by day n. So that's why this is the answer. Finally, this problem was way easier. I don't understand why this is Q4, but basically, let's say answer xy or dpxy is the number of increasing paths starting from cell xy. And it's really simple. You have one path where you just stay there and do nothing else. And then in every other path, you must traverse to a neighbor. So we just iterate through the neighbors, and if that neighbor has a higher value than our current one, we will increment our current dp value by that dp value. And that's because this means that we have a path which is like xy, and then we go ij, and then this, yeah, it's a path which after xy visits ij. And the number of ways to fill in this remaining thing is just answer ij, and that's why we have this recurrence. in terms of why this DP works, because if this was non-increasing path, this would not work. But the reason it does work is because basically on a DP, you need to prove that the states and transitions form like some directed acyclic graph. When you call recursion, you should never be able to get back to the same state, because if you call yourself, you'll end up in an infinite loop. But luckily, since we are always increasing our value, it's impossible to come back to where we are, since we guarantee that our value is increasing all the time. So that's why the DP works. Then finally, we just sum up all the DP values and that's it. It's pretty simple. Yeah, you might have noticed that I tend to use n as rows and m as columns, so I usually switch them around. I had to switch them around in Q2 as well because they were defined differently. But yeah, anyway, it's time to find out how I did. It looks like I got rank 3. I really wanted rank 2 because rank 2 is the gaming mouse, and that is the only item that I haven't won yet. So right now I'm getting another backpack, and I don't really want another backpack. Yeah, but anyway, I'm pretty happy with my performance. I definitely could have done better on Q3. That was the slow question for me. Like that's a very long time, and I'm not very happy with that question. But otherwise, it was pretty good. And yeah, that's all I have today. And thanks for watching, and I'll see you guys next time.